Welcome, everybody. This is Dr. Mark Gordon in Sioux Falls, South Dakota, and we're going to be talking tonight about NRF2, why it's such an important deal, why you're going to be hearing more and more about it, and why we feel that we are on the cutting edge or the tip of the spear, so to speak, when it comes to this NRF2 technology. You need to make a disclaimer here that this cannot be recorded in any way, shape, or form. If you have people who you don't have on this tonight that you wish were on, don't worry, we'll be doing more of these. And the message just keeps getting better and better as more and more research comes in. So we have to get back to the basics to have a discussion here about NRF2, and that is oxidative stress. What exactly is oxidative stress? Oxidative stress is a disturbance in the balance between the production of reactive oxygen species, otherwise known as free radicals, and antioxidant defenses. So, for example, we're all exposed to oxidative stress on a daily basis, and our ability to fight that oxidative stress determines how much of an effect the oxidative stress has on damaging our cells. And if you look at the main actors that cause oxidative stress, those free radicals, they're listed here. There's the superoxide anion, peroxynitrite, hydroxy radical, and hydrogen peroxide. Now, the chemical reaction that you want to see go through is when your body utilizes oxygen and it finally gets converted to water and oxygen again. And there are these intermediate steps, these intermediate molecules that you go through the process to get to the water and the oxygen. These molecules, like for example superoxide anion and peroxynitrite, are extremely toxic molecules that cause significant damage. These are the free radicals. The ones in red here are the free radicals. And they're the ones that if they build up in significant quantities will cause more and more damage to your cells. Now, there are certain things that catalyze these different reactions so that you can get to the inert substances at the end, the water and the oxygen. And those things happen to be superoxide dismutase, or SOD, glutathione, and catalase. And so if you're deficient in these things, then these free radicals have more of an ability to build up and cause damage in your system. But if your SOD, glutathione, and catalase are up to the levels that they should be, you should catalyze this reaction all the way to water and oxygen with minimal, if any, production of these free radicals that cause the damage. So eating food causes free radicals to build up in your system, just everyday life. But if you're deficient in the SOD and the catalase and the glutathione, you're going to have problems as those free radicals cause damage to the cells. So in addition to just normal metabolism and eating, there are other things that cause free radical damage in our bodies. And here's just a list of some of those things. Smoking, alcohol, pesticides, poor diet, inflammation, pollution, drugs, radiation. I'm a cardiologist. I'm in a cath lab all day. I'm exposed to the X-ray tube when I'm doing my angiograms, and that concerns me. There's a cardiologist that I know who taught some of the anti-aging courses that I went through. He was an interventional cardiologist. He spent a huge amount of his life in the cath lab. Very clean living guy, ate right, exercised, did all the right things. And he had a screening of his carotid arteries one day, and he had plaque that was building up on the left, but no plaque on the right. And he thought about it for a bit, and he said, you know what? My left carotid is the one that is exposed to the X-ray tube when I'm doing my heart caths all day long, and so it only makes sense that I would have plaque build up there and not on the other side. So the radiation really does cause damage. And the longer you're exposed to it, the more damage it can do. Injury, trauma, aging, infection, too much and not enough exercise, all of those things create more free radicals, increasing the oxidative stress, leading to cellular aging, disease, and ultimately death. Now, what organ systems are affected by oxidative stress? Every one of them. And here is a list of some of the things that happen from oxidative stress with regard to these different organ systems. So in the heart, for example, which is my area of specialty, myocardial infarction, hypertension, cardiac fibrosis. I even read a study tonight about left ventricular hypertrophy or thickening of the heart muscle being related to oxidative stress. In the skin, psoriasis, dermatitis, melanoma. Kidneys, kidney failure, in the joints, rheumatoid arthritis, osteoarthritis, psoriatic arthritis. In the lungs, asthma, COPD, cancer, allergies, ARDS. In the brain, there's a lot of research going on right now about the role of oxidative stress and NRF2 in the brain. Oxidative stress leads to Alzheimer's, Parkinson's, ADHD, autism, migraines, stroke, cancer. In the immune system, chronic inflammatory conditions like rheumatoid arthritis, lupus, inflammatory bowel disease like ulcerative colitis and Crohn's, different types of cancer, multiple sclerosis. In the blood vessels, hardening of the arteries, atherosclerosis, endothelial dysfunction, which is the first thing that happens in the blood vessel as you start to develop disease in your arteries. Diabetes, chronic fatigue syndrome, aging, macular degeneration, retinal degeneration, cataracts, all of these things have as their root cause oxidative stress. So when you start to talk about something that has a potential effect on reducing oxidative stress, you can see why it has the potential to affect so many different conditions. So oftentimes people say to me, well, gee, if you have something that fixes all those things, it's got to be too good to be true because there's nothing that does all that. Well, if you begin to understand that it's the oxidative stress that's the common denominator, then you start to realize how it is that attacking one system like NRF2 can, in fact, have an effect on so many different things. Now, the way that we have historically tried to deal with this problem of oxidative stress is by taking antioxidant vitamins, things like vitamin E, vitamin C, beta-carotene, and so forth. And those types of antioxidants work like what's shown in this picture here. You have an antioxidant molecule. You have a free radical that's got an unpaired electron in its outer shell. This antioxidant molecule donates an electron, satisfies the outer shell of the free radical, neutralizes the free radical, but it's a one-to-one arrangement. So this antioxidant uses up its only available electron to neutralize that free radical, and it can't neutralize anymore. Well, so for decades, what people did who were health conscious was started taking these types of supplements, vitamin E, vitamin C, beta-carotene, in large quantities, thinking that they were helping to fight the free radicals that were causing the cellular damage. But we now have very large trials from very well-respected journals, such as the New England Journal of Medicine, the Annals of Internal Medicine, and so forth, proving that in large studies with tens of thousands of patients that taking excessive amounts of these vitamins may actually cause more harm than good. They actually increase the risk of certain types of cancer. In this study, it was prostate cancer. It can also increase the risk of heart disease in some people. So what we thought to be a good thing 10, 20 years ago turns out to not be a good thing. And the reason why it's postulated is because those antioxidants, when they neutralize those free radicals by getting rid of an electron or donating an electron, they themselves become antioxidants. And so the result of that is you can set off a chain reaction if you've got too many of these antioxidant molecules floating around. You can imagine if this antioxidant molecule becomes a free radical, it's going to go try to find an electron from another antioxidant molecule, and you can set off a chain reaction. So what you were taking as an antioxidant, when you take too much of it, actually becomes a pro-oxidant. So it's postulated that that's the reason why all of these studies showed a detrimental effect by taking excessive amounts of these types of antioxidant vitamins. So what we've learned is that these direct antioxidants cannot neutralize free radicals as efficiently as indirect antioxidants. And the indirect antioxidants are the SOD, the glutathione, the catalase, and hundreds of other compounds. And these are actually antioxidant molecules that your own body makes. They're not things that you take in from the outside, and that's why they're called indirect or endogenous antioxidants. So there is a better way. There's a better way to help improve the antioxidant enzyme levels in your body and thereby reduce the free radical damage that's occurring to your cells. And that happens to be through this new pathway that was identified in the mid-90s called NRF2. Now, prior to my introduction to this company and this product, I had no knowledge whatsoever about NRF2. And the reason why is it was discovered around the tail end of my medical training. And frankly, prior to Protandim, there had not been any NRF2 activating compounds available in any sort of clinical form. And so there was really no discussion of this at all through any of my medical school or residency or fellowship training. But it's starting to catch on now. And for some of you know that I've done a fellowship in anti-aging and metabolic medicine, and they are now starting to talk about this NRF2 pathway in those types of conferences. So you are going to be hearing more and more about this. So what is NRF2? It's a messenger protein. It's in every cell in your body. It activates genes. It's involved with redox balance, and it's a master regulator. Let me just show you schematically how this works. So if this is a cell surface, you have a NRF2 activator that comes and attaches to a receptor on the cell surface, and it causes a conformational change in this protein called KEAP1, which is attached to the inside of the cell membrane and to the actin molecules. And so when the NRF2 activator comes, it causes KEAP1 to release NRF2. So NRF2 then goes from the cytoplasm into the nucleus of the cell. We've got wonderful immunofluorescent staining techniques that prove that. And then it attaches to a segment of DNA called the antioxidant response element. And then it affects the genes downstream on that strand of DNA. And it either causes upregulation or downregulation of the genes depending upon what it is that they code for. And in a nutshell, what happens is it upregulates the good stuff and it downregulates the bad stuff. It upregulates the anti-inflammatory, anti-fibrotic, antioxidant enzymes, and it downregulates the pro-inflammatory, pro-fibrotic proteins. So you get the best of both worlds, more of the good, less of the bad. Now, there are several different compounds out there that can activate NRF2. And there are several different places in the NRF2 pathway that you can activate it. And this slide is to just remind me to tell you that there are so many different attachment points for things to cause an effect on NRF2 to either increase its activity or decrease its activity. And most synthetic drugs that are NRF2 activators work on one specific part of the pathway. So perhaps they cause increase of the release of NRF2 from the KEAP1 holding protein. Or maybe they cause it to more easily enter the nucleus from the cytoplasm. Or maybe they cause it to attach to the antioxidant response element better. So each individual compound that is a drug will act on one of those specific pathways. And one of the other things that you need to know about this NRF2 pathway is it's not turned on or turned off all the time. It works in a pulsatile fashion, and that's the way that it was intended to work. And by taking a NRF2 activator as directed, you will not turn that thing on 24/7. So some people have said that turning on NRF2 24/7 is a bad thing, and I would agree with them. And NRF2 activating compounds do not do it that way. They do it in this pulsatile fashion. Certain types of cancers cause mutations in the NRF2 pathway, either in the NRF2 molecule itself or KEAP1 or any of the other proteins that are associated with that. And through that mutation, sometimes these cancer cells turn on NRF2 24/7 in that particular cancer cell, and it's the cancer's way of trying to keep it alive for a long time. So people have said well, you shouldn't give NRF2 activators in cancer because you might make the cancer cells live longer. Well, the argument on the other side is that if you have a cancer and the cancer has caused mutations in KEAP1 and NRF2 so that the NRF2 is turned on all the time, you can't make that NRF2 be turned on anymore if it's already fully on. So it's like if the gas pedal is all the way to the floor, you can't push it any farther. You can't push it through the floor. And I'll talk a little bit more about cancer later in the discussion here tonight. But there's some controversy about cancer. We'll get to that. So why is it that I had not heard about NRF2 in my medical training? Because I did my medical training back here, and these are the studies that have been done on NRF2 published in PubMed, the National Institutes of Health website for medical research. And you can see that now by the end of 2014, there have been over 5,000 articles published about NRF2. We are just getting started with this. One of the things that's been proven is NRF2 declines with age, and therefore oxidative stress causes more damage. So why is that? Nobody's completely sure why NRF2 goes down, but it seems to become less and less active. And so they've proven this in animal models that the older ones have less NRF2 activity and subsequently have higher levels of oxidative stress. Now, there are multiple companies and multiple universities that currently hold patent on NRF2 activating compounds, synthetic NRF2 activators. And you're going to be hearing more and more about these different companies that have all of these products that they're studying in specific disease states. For example, Abbott Pharmaceuticals and Reata have partnered up. Abbott is a big powerhouse in the pharmaceutical industry, and Reata is more of a small biotech company. Reata has a pipeline full of synthetic NRF2 activating drugs that they're studying in a variety of different diseases. And I'll talk about one of their drugs a little bit more in a moment. The only currently available NRF2 activating drug that's out there is made by BioHACK, and it's a drug called Texadera. And Texadera has been found to be beneficial in multiple sclerosis, and I'll talk more about that in a moment as well. So there are multiple companies, universities that have synthetic NRF2 activators, but there are natural NRF2 activators as well. And these are just some of the studies that have been done on Protandim, which is an all-natural NRF2 activator. And we've had research published in some of the most prestigious medical journals in the world, including Circulation, which is the journal of the American Heart Association. That's the article that caught my attention because I know Circulation, being a cardiologist, and I know that they don't publish studies about snake oil. So when I read this study about chronic pulmonary artery, basically pulmonary hypertension and right heart failure, and the effect that Protandim had, I was all in. I knew at that point that this was the real deal, and there was legitimate science behind it. So what is in Protandim? Protandim is a combination of 5 plants: green tea, turmeric, milk thistle, ashwagandha, and bacopa. And each of these have their own unique actions, but what they found when they put these 5 together is that it caused a significant increase in these antioxidant enzymes. In this particular study, they looked at hemoxygenase mRNA. And if you look at the individual ingredients, they have really little effect at all increasing the production of this. But when you put the 5 together in the combinations in Protandim, there was an 18-fold increase in the expression of this antioxidant protein. So it's not 1 + 1 + 1 + 1 + 1 = 5. It's 1 + 1 + 1 + 1 + 1 = 18. So there's truly a synergistic effect. So when I had a discussion with Dr. McCord about this, the developer of, or the one who helped put this together, and I told him, I said, I don't understand why it is that there would be such a profound increase by adding these together. And he said that synergistic effect probably has to do with the fact that each one of these things may act on a different place in the NRF2 pathway. And by acting on a different spot in the NRF2 pathway, the 5 together can have a much greater than additive effect, and it's likely that that's why there's such a great increase in activity with the 5. This was the first study that was published with Protandim, and in this particular study, they showed a couple of things. First, superoxide dismutase increased by 34% after 120 days, and they had to do it for 120 days in the study because they were measuring it in blood cells, and the blood cells turn over every 120 days, so you had to wait for a complete cycle to pass to measure it. And catalase increased by 54%. The more profound thing that they saw, however, was the reduction in oxidative stress measured by T-bars. And so if you look at this black line here, this was the baseline group, okay, and their level of oxidative stress based on age. So they went from people from the age of 20 all the way up to the age of 80. And as you can see, as you get older, the oxidative stress level increases. And one of the interesting things that they saw was that those people that were taking supplements of vitamin E and vitamin C actually had higher levels of oxidative stress than the baseline group that was not taking any vitamin E or vitamin C supplements. Now, it did not reach statistical significance, but there was a trend towards higher levels of oxidative stress in those people that were taking those supplements. Now, when they took Protandim for 30 days and they measured the T-bars again, everybody's oxidative stress level was reduced down to that of a 20-year-old. Didn't matter where they started. On average, it was reduced by 40%, and it was highly statistically significant. That is a big deal. There is no other supplement or drug that I am aware of that can make that statement. So an average reduction of 40% in oxidative stress levels. An article that came out in February of this year, and it's a fantastic article for anybody who really wants to dig deep into NRF2, what it can do, what it's been proven to do in different studies. And I'm going to talk a little bit about some of the findings that were discussed in this article. So one of the things about NRF2 is it's a gene regulator. As I mentioned, it upregulates and downregulates things. It upregulates the good genes via NRF2. NRF2 has another effect on another messenger protein called NF-kappa B. NF-kappa B is responsible for all the bad stuff. So when NF-kappa B is stimulated, then you get pro-inflammatory, pro-fibrotic products that are made. But NRF2 downregulates NF-kappa B, so it downregulates the production of all of that bad stuff. And then there's some other effects that the NRF2 has on other gene transcription and so forth. NRF2 has been studied with regard to the antioxidant effects and the protective effects on the cell. Cytoprotective means cell protection. And there's a lot of different agents that NRF2 activates or increases the production of that help with this cell protection. We've talked about some of them: glutathione, superoxide dismutase, and catalase. But there are a number of others that we rarely ever touch on, but these are very important compounds to help get rid of toxic molecules in our bodies. There have been studies with NRF2 activating compounds looking at cell protection in a variety of different conditions. Decreased susceptibility to cancers, many different types of cancers, protection from neurodegenerative diseases like Parkinson's and Alzheimer's, protection of lungs and lung disease, protection of the liver and the GI tract, and reduction in inflammation. And one of the big things that NRF2 does is it's very important in the detoxification pathways. And there's a lot of genes, 25 different genes, that code for enzymes that detoxify these xenobiotics, these foreign molecules that we take into our body, ingest into our body every day. And one of the things that's critical in this detoxification pathway is glutathione. So NRF2 is the primary responder to toxins that are taken in and a variety of different things. there's only one individual, actually a couple now, but in the early days there was only one individual that I spoke to about NRF2 who knew what it was before I had a discussion with him. And that happened to be my brother, who's a toxicologist. He works for 3M. And I asked, how do you know about NRF2? And he said, well, it's critically important in heavy metal detoxification. So him being a toxicologist, he knew that. So there are a few people out there who you'll bump into from time to time who may have an understanding of what NRF2 actually is, but they're few and far between. So what about glutathione? Glutathione is dramatically upregulated or increased in production with NRF2 activation, in some studies as much as 300%. It is the most important detoxification enzyme. It also is an antioxidant, and it's also important in the nitric oxide cycle, which is what regulates blood vessel health. It's also involved with repairing DNA, making proteins, activating enzymes, and every organ system in your body is affected by glutathione. People who are highly toxic, who have lots of toxins in their body, typically have very low glutathione levels. And I'll show you why. There are two phases of detoxification. Phase 1 and Phase 2. Phase 1 uses the cytochrome P450 system. Phase 2 uses conjugation pathways. And so when you take a foreign molecule into your body, it goes through Phase 1 detoxification in the liver through the cytochrome P450 system. And then that converts the molecule into an intermediate metabolite, so an intermediate molecule. Then Phase 2 kicks in, and it converts that molecule into something that is harmless, that can be excreted in the urine, bile, or in the stools. Well, the one most important molecule involved with both Phase 1 and Phase 2 is glutathione. So these people who are highly toxic tend to have very low glutathione levels. And what ends up happening is they can probably get through Phase 1 detoxification okay, but they build up these toxic intermediate molecules that they can never get rid of in Phase 2. And these intermediate molecules oftentimes are more toxic than the parent compound that you adjusted in the first place. So they get a buildup of all these toxic intermediate molecules and all of the associated health conditions with that. So one of the things that you do sometimes see in a patient like this who's highly toxic, if they start taking a NRF2 activator, they may go through what we call a detox reaction. And what that is essentially their body, when you start to rev up their glutathione levels and get them up to where they need to be, Phase 2 and the detoxification pathway starts working again. You start mobilizing these toxic intermediate molecules, and you start getting rid of them. But in order to do so, they have to pass through the bloodstream. So as they're passing through the bloodstream, these toxic molecules, you may actually feel sicker before you start to feel better. So in people who have that effect, and it's rare, maybe 1 in 100, we typically tell them to reduce their NRF2 activator to maybe half or a quarter of a dose for a while until they can get through that detoxification phase, and then hopefully they'll be able to tolerate it from there on out. There are numerous anti-inflammatory effects of NRF2. It works through multiple pathways. I'm not going to get into all of them. Interleukin 1, interleukin 6 are pro-inflammatory proteins that are suppressed with NRF2. Interleukin 10 is stimulated by NRF2, and that's an anti-inflammatory compound. So this gets a bit complicated, but just suffice it to say that there are multiple anti-inflammatory proteins that are induced by NRF2. NRF2 and inflammation has been looked at in a variety of different conditions, from autoimmune disorders to asthma to neurodegeneration. I mentioned Parkinson's and Alzheimer's, pulmonary fibrosis, osteoarthritis, cardiovascular disease, and cancer. Mitochondria are the powerhouses of the cells, and if the mitochondria are not working well, people get very, very sick. And mitochondrial biogenesis is actually regulated through the NRF2 pathway. So people, again, who have very low NRF2 levels tend to not have good functioning mitochondria. And activating that NRF2 can get those mitochondria working. There's a lot of different theories as to why that may be, but it's an important thing to know because a lot of muscular diseases are related to mitochondrial dysfunction. So there's a lot of work going on right now with Nerf2 to look at these mitochondrial diseases and see if there may be benefit there. Chances are there probably will be. There's another protein called AMPK that there's crosstalk between it and Nerf2. AMPK is another anti-aging pathway that helps to monitor the energy levels in the cells. And one of the other things that Nerf2 does is it helps with autophagy, which is removal of damaged cell parts. Basically, it's helping to get rid of the junk that can build up in your cells that can interfere with normal cellular function. Antifibrotic effects of Nerf2 have been proven in the liver, lungs, kidneys, and that works through several other proteins. Cellular integrity and Nerf2, there's numerous studies about how Nerf2 interacts with this p53 tumor suppressor transcription factor to protect cells against the development of certain types of cancer. Longevity has been looked at with Nerf2, and in general, what they have found is that those creatures that have the highest levels of Nerf2 tend to live the longest within their species, and those with the lowest levels of Nerf2 have the shortest lifespans. Neurodegeneration we talked about, they studied this Nerf2 in Parkinson's and Alzheimer's disease, and also some other neurological conditions we'll get to. So here we go. Parkinson's, Alzheimer's, ALS, traumatic brain injury, multiple sclerosis, and nerve cell protection have all been looked at with Nerf2, and there are articles, numerous articles, showing positive effects on all of these different conditions. I'm not going to go through all of these articles in great detail, but this one in particular talked about how Nerf2 may be a multi-organ protector. This talks about the importance of Nerf2 in immunological disorders. And in this particular article, they showed that Nerf2 played an important role in Parkinson's, Huntington's, chorea, and other neurological conditions. It was important in stroke, and they found that oxidative stress played an important role in these neurodegenerative conditions and in Parkinson's disease. Neuroprotection is one of the big areas of research with Nerf2 right now. Several of the companies are studying their synthetic Nerf2 activators on neurological conditions, and as I mentioned, Texadera has been studied in multiple sclerosis. Just breeze through some of these here because we've got a lot of material yet to cover. For those of you that are keeping track, we're on slide 47, and I think I have 133 slides, so we got to get moving. These are some of the pharmaceutical companies and universities. These are the patents that they have on the compounds that are Nerf2 activators. And this shows some of the different things that they're studying. Traumatic brain injury, concussions, so forth. Nerf2 has been studied in these conditions and has been found to be beneficial in recovery from traumatic brain injury. One of the things that it does is it protects the blood-brain barrier, and it also has anti-inflammatory effects that probably help with the healing of the brain. Ischemic stroke, ischemic as opposed to hemorrhagic. The difference is ischemic is you shut off blood flow to the brain, and hemorrhagic is you bleed into the brain. Nerf2 has been found to be beneficial in recovery in both of those conditions. Parkinson's disease being actively studied right now by a variety of universities looking at Nerf2 and how that may be beneficial. One of the things that seems to be fairly common in these neurological conditions are the fact that the glutathione levels tend to be reduced. So it might be, at least in part, that the Nerf2, one of the protective mechanisms of Nerf2 in these conditions may be by raising the glutathione levels. There's a very interesting video on YouTube that you can look at of a gentleman who has Parkinson's disease, and he gets an IV infusion of glutathione, and it looks like he's a new man. So glutathione does certainly play a role there. Cerebral inflammation can be suppressed with Nerf2 activation. Now, we're talking about Parkinson's disease. Many of you guys know the Michael J. Fox Foundation for Parkinson's Research, and they are now actively studying NRF2 as a protective mechanism in Parkinson's disease. So don't know where they're at in the research on that and how much longer it's going to be, but it'll be interesting to see that study when it comes out. They said lots of people doing research in Parkinson's disease, and one of the other aspects I mentioned about the glutathione, but the mitochondrial dysfunction that can be improved with NRF2 activation may also be one of the ways in which it helps in that particular disease. Alzheimer's disease, they have found decreased levels of NRF2 in a certain part of the brain called the hippocampus in patients that have Alzheimer's disease. And they found that if you increase NRF2 activity, you can reduce the cell death in that part of the brain. So there may be some benefit in Alzheimer's. We don't have any definitive studies in that area yet, but certainly that's an area of active research. Now, with Protandim specifically, the first thing I have to mention to you is Protandim is not a drug. It's a supplement based off of 5 plants. And as a supplement, we can't make any claims that it cures, treats, or prevents any particular condition. What I can do, though, is show you the research. And they have looked at Protandim on the genes associated with Alzheimer's disease. And with Alzheimer's, there are actually 66 genes associated with that disease. And if you look at what happens when you take Protandim, of the 66 genes, 43% of the genes were modulated by Protandim in the opposing direction of the disease, meaning that if the disease activated that particular gene, Protandim turned it off in 65% of those particular genes. So that, again, NRF2 is actively being looked at in Alzheimer's disease. Multiple sclerosis. This is the one specific disease where they do have an FDA indication for a NRF2 activating agent, a drug called Texadera, made by BioHACK. The chemical name for Texadera is dimethylfumarate, and it promotes NRF2 activation through direct modification of the KEAP1 protein, that holding protein. So they've done 2 studies with this drug that were very, very landmark kind of trials in MS. And in this particular study called the DEFINE trial, they showed a 49% reduction in relapse rates at 2 years in the patients that were taking the drug. They then did another study called the CONFIRM trial, and in this particular study, they showed a 44% reduction in relapse rates at 2 years. So that's pretty amazing. And this particular drug, in its first year, sold $3 billion worth of product. And in their second year, I think it was $4.2 billion. I think it became the most widely prescribed multiple sclerosis drug in the United States in just the first 2 years of its use. Now, this is another article that I oftentimes refer people to because it gives you a great synopsis of what NRF2 is, gives you some background information on NRF2, and there's some comparative data with other compounds. So this is an article that was done by Dr. McCord, and in this particular study, one of the things that they did is they did a side-by-side comparison of NRF2 activating compounds. They looked at Protandim, bardoxolone, BG12, and sulforaphane. In this particular study, this head-to-head comparison, they looked at the ability of these agents to activate NRF2, how effective they were, and it was quite interesting what they found. So Protandim, in this first box, box A, had the highest NRF2 activation levels, even higher than bardoxolone. That's a drug from Reata and Abbott, and higher than dimethylfumarate, Texadera. And this is sulforaphane. This is the active ingredient in broccoli, which is also a NRF2 activator. But Protandim was actually twice as potent as bardoxolone and dimethylfumarate, or Texadera, inactivating NRF2 and 6 to 7 times as potent as sulforaphane. And when I first saw this study, I was amazed, and I talked to Dr. McCord about it, and he said it's again because of that synergistic action and the fact that it tends to affect perhaps several different places in the keep 1 NRF2 pathway, and by doing so you can get a much higher activation of NRF2. Now, that particular study was done by Dr. McCord at the University of Colorado, and some people will say, well, maybe he's biased because he worked for LifeVantage at the time. So here's another study that was a direct comparison between BG12, which is Texadera, this TBHQ, which is another synthetic NRF2 activator, sulforaphane, the broccoli ingredient, and Protandim. They were compared in this study looking at NRF2 activators in multiple sclerosis. And this study was actually funded by Biogen IDEC, the company that makes BG12. Let me just read to you one of their conclusions. Our findings indicate that several NRF2 activators are able to significantly increase antioxidant enzyme production in oligodendrocytes. Interestingly, Protandim, a dietary supplement consisting of herbal ingredients, was the most potent inducer and therefore may be the most suited as a therapeutic strategy. That was not LifeVantage saying this. That was the researchers who got grants from Biogen IDEC who said that. That's pretty profound. So does NRF2 help nerves survive? It would appear so from all the research that's been done. And if you look at Huntington's disease, they've shown promise in the treatment of Huntington's disease with NRF2 activation. ALS, actively studies going on right now, and I had a phone call with a researcher from Duke University last week who wants to do more research with regard to NRF2 in ALS. So an active area of research once again. This is a particular study that was looking at acute mountain sickness and showed that NRF2 activators with Protandim or other off-target effects of other compounds before high-altitude hypoxia reduced cerebral vascular leak, basically that it could be a potential treatment for acute mountain sickness, which I wish I would have had when I tried to climb Long's Peak many years ago. Now, this is a very interesting article looking at how NRF2 can protect the brain cells against ethanol-induced apoptotic death. For those of you that don't have a scientific background, what does that mean? That means that, let me read their conclusion. These studies illustrate the importance of NRF2-dependent maintenance of glutathione homeostasis in cerebral cortical neurons in defense against oxidative stress and apoptotic death elicited by ethanol exposure. So everybody's heard that if you drink too much alcohol, it kills brain cells. Activating NRF2 has the potential to prevent that from happening. But I still haven't called the guy that owns this company called Hangover Heaven, but he offers some therapies for people who imbibe a little too much and they travel around in a bus to different events like motorcycle rallies, I presume. And they have 3 different recipes that you can get, the redemption, the salvation, or the rapture. And I would think it would be interesting to include a NRF2 activating compound in their cocktail and see how that works for them. This is another article that I frequently reference to folks who are trying to get a handle on what NRF2 is. NRF2, guardian of health span and gatekeeper of species longevity. It gives a great synopsis of what NRF2 does in the specific organ systems. So it'll go through the heart, the liver, the GI tract, everything, and tell you all the studies that have been done on NRF2 on organ-specific things. And this is one of their conclusions. There's mounting evidence across evolutionarily distinct species that the NRF2-dependent components are associated with longevity and extension of health span, meaning that the individuals age, but they stay healthy longer through their aging process. Now, this is from that first article that I mentioned that came out in February from Washington State. This is a table from that article looking at specific diseases where activating NRF2 has been found to be useful in prevention and or treatment. And this is a pretty wide list of things, from cardiovascular diseases, including atherosclerosis, ischemic disease, vascular endothelial dysfunction, heart failure, neurodegenerative diseases, Alzheimer's, Parkinson's, ALS, Huntington's disease. We've talked about those. Cancer prevention, I've got a few more words to say about that towards the end. Chronic kidney disease, bardoxolone, the drug from Reata, was looked at initially in chronic kidney disease. It looked very promising, but they had some problems with side effects. Metabolic diseases such as type 2 diabetes, toxic liver disease, chronic lung disease, asthma, emphysema, pulmonary fibrosis, sepsis, autoimmune disease, inflammatory bowel disease like Crohn's and ulcerative colitis, HIV/AIDS, multiple sclerosis, and epilepsy. Now, this is a laundry list of a lot of different things, and again, their common denominator is oxidative stress as the root cause. So you can imagine, if you can reduce oxidative stress through the Nerf2 pathway, how it is that you could affect so many different seemingly unrelated conditions. So being a cardiologist, I'm often asked, well, what does Nerf2 activation do in the cardiovascular system? Well, we have studies that show that it protects endothelial cells from inflammation. So in order to get an atherosclerotic plaque to develop in your artery, you have to have two things. You have to have cholesterol and you have to have inflammation. We have good drugs that treat the cholesterol part, but we don't have good drugs that treat the inflammation part. So activating Nerf2 may be beneficial in that regard. It upregulates detoxification enzymes, so you may actually protect against ischemic injury. When I was a cardiology fellow, one of the studies that we were doing was in patients who were having heart attacks. We were injecting superoxide dismutase down their coronary arteries to try to reduce the size of the heart attack. That's what they're talking about here. It mediates mitochondrial biogenesis. So one of the problems in patients that have heart failure is their heart muscle cells aren't working as well as they should. So there's some suggestion that if you activate Nerf2, make their mitochondria work better, their muscle cells in their heart may work better as well. And I don't know of any particular studies that have proven that, but I've seen clinical cases that has actually happened. So it reduces the damage to the cardiovascular system from oxidative stress, can prevent right-sided congestive heart failure related to pulmonary hypertension, and it can prevent intimal hyperplasia in vein grafts, or plugging up of vein grafts that are used for bypass surgery. Atherosclerosis is the bane of my existence. I deal with it multiple times a day, every day. Atherosclerosis is plaque buildup in the arteries, which leads to heart attack in the heart, stroke in the brain. So there are 19 genes that are associated with atherosclerosis. And this is another one of the genetic studies that was done with Protandim, and it looked at the effect that Protandim had on that. And what they found is, of the 19 genes, 16 of them, or 84%, were modulated by Protandim in the opposing direction. Again, so if the disease caused the gene to get turned on, then taking Protandim caused it to get turned off. And again, I'll emphasize that Protandim is not designed to be a treatment for any specific disease or prevention of any specific disease, because it is a natural supplement. We're not allowed to make such claims. Now, I mentioned to you Reata. That's the company that's got a lot of drugs in the pipeline, some really good drugs that probably will find their niche for treating specific diseases. But their one drug, bardoxolone, that they were studying in kidney failure, they've now started looking at it in pulmonary arterial hypertension as a potential treatment. And that is a study that was done, and I believe it's already been presented. I have not been able to find the actual abstract from that study yet, but I've heard that it was a very positive study, and I suspect that there'll be more studies from them in that regard as well. Now, as I told you earlier, the article that really caught my attention about this whole Nerf2 thing was this article right here, the one in circulation. And what they found in this article, in this study, was that Protandim prevented the fibrosis and the capillary loss and preserved heart function in pulmonary arterial hypertension, which is pretty profound, and we could go into great detail about this, and I'd love to because I'm a cardiologist. But basically what they found is that when you cause pulmonary hypertension in this animal model, it always led to right-sided congestive heart failure. But if they treated the animals with Protandim, the Protandim seemed to have a protective effect on the right heart, probably by protecting those heart muscle cells so that the right heart did not fail. And so this was a review article that talked about looking at this NRF2 pathway as a potential treatment for patients with pulmonary hypertension. And there's a couple of ways in which that could happen. This article actually talked about Protandim as a potential treatment. We can't do that, but these researchers can. And what they talked about was there's two stages that NRF2 activation may be beneficial in. The very early stage, the preventive stage, is when you start to get the problems that lead to the pulmonary hypertension, the thickening of the walls of the arteries in the lungs. That's something that you don't really know is going on until after you get the full-blown disease. But if reducing that oxidative stress can have a preventive effect on that happening in the first place, that's obviously the better way to go. But the other thing, and based on the studies that was reported in Circulation and some other studies, what these researchers said was that this antioxidant effect can be protected on the right ventricle, and they specifically cited the study that was done with Protandim looking at that. They also believe that carvedilol and perhaps vitamin C may have a protective role there as well, but the research isn't as good with vitamin C. It's fairly good with carvedilol, but it was certainly shown in that one animal study, at least with Protandim, but again, no human studies there. Another study that for me as a cardiologist really got my attention was this one that talked about how Protandim can prevent this intimal hyperplasia that leads to buildup of blockage inside vein grafts when they're used for coronary artery bypass graft surgery. So if we look at these pathological slides, this box A is what a new freshly removed vein looks like. So this is the inside of the vein, this is the outside of the vein. So the intima is the inner lining, the media is the middle layer, the adventitious is the outside. So when you take a vein out of the body and you expose it to arterial pressures and arterial oxygen levels, the veins were never designed for that, and so the vein responds with this inflammatory response, and it starts to bring in all these inflammatory cells into the intima, and the intima thickens significantly. Here it's just a couple of cells thick. Here it's dozens of cells thick. And so this process goes on throughout the life of the bypass graft, and thus the bypass graft narrows from the outside in. So when they treated the same veins with Protandim and exposed them to the same levels of oxygen and blood pressures, they had no thickening of that intima whatsoever. That was truly amazing. One of the other articles talked about how you can actually protect the human endothelial cells within the arteries. So the endothelial cells are the lining cells inside the coronary arteries, and they found that Protandim had a protective effect against the oxidative damage that was done to those particular cells. Another study looking at the upregulation of the phase 2 enzymes with NRF2 activation and how that can protect the heart muscle cells. So this was the glutathione stuff, how that had a protective effect through NRF2 activation in heart muscle. There is a good article out there that if you want to get more detailed about specifically what NRF2 can do in cardiovascular disease, I would encourage you to pick up this article. It talks about several different heart-related conditions and how activating NRF2 may be of benefit in those. Now, this is actually a PhD thesis that was looked at, where they looked at the role of NRF2 in mitochondrial function. And one of the conclusions was as many human pathological conditions have oxidative stress, inflammation, and mitochondrial dysfunction as essential components of their pathogenesis or their cause, activation of NRF2 holds promise for disease prevention and treatment. So remember I mentioned how mitochondrial disease may play a critical role in many muscle diseases, heart diseases, and neurological diseases. And there's new evidence to suggest that activating NRF2 may have a protective effect there. Now, I mentioned early on that study with Protandim, how it showed a 40% reduction on average in oxidative stress measured by those T-bars. And so people have often asked me, well, T-bars, I've never heard of T-bars. What are T-bars? T-bars is a measure of oxidative stress or cellular aging, whichever way you want to look at it. And does it have any clinical relevance? Absolutely it does. This was a study that was published in JACC, the Journal of the American College of Cardiology, back in 2004. And what they found, and I have no idea why this study didn't get more press than it did. You would have thought that the press would have been all over this because this was a really big deal. If you look at the results, they measured T-bar levels, and they put people into four quartiles from lowest T-bars to highest T-bars. And what they found is when they compared the people with the lowest T-bars versus those with the highest T-bars, the reduction in cardiovascular events was profound. There was a 5-fold reduction in heart attack going from the highest T-bar level to the lowest T-bar level. And every type of cardiovascular event you can think of was significantly reduced in those patients that had the lowest T-bars. So would lowering T-bars be a good thing? Yes, it would seem that would be the case. And this article from way back in 2004 in the American College of Cardiology actually proves that. What about cancer? There's a whole lot of research going on with cancer right now. There's a lot of misunderstanding and misconception about NRF2 and cancer. And so because of that, there are people who feel strongly on both sides of the issue about taking a NRF2 activator during chemotherapy and so forth. And so I always leave that up to the decision of the oncologist who's treating the patient. He knows their condition and their problem much better than I. But I just want to go through some of the stuff that there is out there about cancer in NRF2. One particular study, again, a genetic study with Protandim, looked at colon cancer, 28 genes associated with colon cancer. Of the 28 genes, 25 of them, or 89% of them, were modulated by Protandim in the opposing direction of the disease process. So again, if colon cancer caused the disease to be turned up, Protandim turned it in the opposite direction in 89% of those cases. Here is a study looking at the protective effects of Protandim on skin cancer done from Louisiana State University. Another study from the same researchers identifying this P53 tumor suppressor marker and superoxide dismutase playing the role of suppressing tumor activity with Protandim. This was a PhD thesis from a gentleman at the Mayo Clinic, a physician, looking at Protandim as an approach to ovarian cancer. And it started with this case, this woman that came to him with metastatic ovarian cancer. And what they had done was they did a debulking procedure, did chemotherapy. This is the CA-125. It's a blood marker of cancer activity with ovarian cancer. And it went down to almost zero. And then the CA-125 level started going up. They found some mets in her abdomen, some metastases. They recommended a repeat chemotherapy. She didn't want to do that. She took Protandim instead, and her CA-125 levels came back down. They also showed CT scans, and these don't project very well, but basically what they found, if you look at 2010 through 2011, there had been some metastases here along the liver, and also in this area here, and that had shrunk when it had gone away completely, and this one has shrunk after 1 year of taking Protandim. So again, we're not saying that Protandim is a cure, treatment, or prevention for any specific disease. I'm just showing you the results of this gentleman's thesis that he submitted to the Mayo Clinic graduate school. and now he's doing additional research looking at Protandim and NRF2 activation for ovarian cancer models. So it'll be interesting to see what further comes from that. Here was another PhD thesis from a person from University of Montreal, looking not at cancer, but rather at arthritis, osteoarthritis. And there's this one particular protein called HNE that is involved with cartilage damage in osteoarthritis. And what they found was that NRF2 activation with Protandim could play a role in preventing that cartilage damage. And so what they said, we found that oral administration of Protandim at 10 milligrams per kilogram per day reduced the cartilage damage. So that's pretty interesting information as well. Again, we can't say that we're a cure, treatment, or prevention for anything. I'm just showing you the results of other researchers' studies. Now, if you look at the individual ingredients, they all have some degree of NRF2 activation, but the combination was clearly the best. And there are actually two preparations. There's the U.S. version and there's the Japanese version. And that has to do with the fact that one of the ingredients was felt to be a drug in Japan, but not in the United States. I think that was the ashwagandha. And so they replaced that with black pepper for the Japanese version. But the NRF2 activation for both the U.S. and the Japanese were very, very similar, nearly identical. So Protandim actually has 7 patents now in the U.S. and 3 international patents because of that unique synergistic action. We had talked about how the NRF2 activation could increase the levels of SOD and catalase and so forth. And this is a study that was done in muscular dystrophy showing a reduction in osteopontin, reduction in T-bars. Osteopontin is a fibrotic protein that tends to build up as scar tissue in the muscles. And this is just a picture from that. The white area here is the scar tissue. So these were the animals that were treated with Protandim. These were the animals that were not. So you can see a significant reduction in the scar tissue. Talked about this article, the NRF2 healthkeeper, or guardian of HEALTHSPAN and gatekeeper of species longevity. Go into any more detail on that. Now, to talk about how big this NRF2 thing is. You know, some people have said to me, is this just a fad? Is this just a passing whim? Is this going to hang on? Is this going to have staying power? Well, the first ever international NRF2 conference took place at Cambridge, England, in January of this year. And we had 2 scientists from LifeVantage who were there presenting abstracts. And one of them, Dr. Sveta Silverman, who is a pathologist from Edmonton, Alberta, was there, and she has such intimate knowledge of what NRF2 does in various cancers and so forth, and it's amazing to sit down and chat with her. She's an incredibly bright individual. She presented research that she did herself on the appearance of breast cancer with NRF2 activation with Protandim. Now, even more recently, the November issue of Free Radical Biology and Medicine, the entire issue was devoted to NRF2. And for any of you science geeks out there, I would encourage you to get your hands on a copy of this. The stuff in there is absolutely amazing. And Sveta was nice enough to take some notes. I haven't had a time to read these articles in detail, but some of the stuff in there, a lot of it is things that I've already mentioned, but more scientific validation for that. And I would encourage you to pick up that article. Maybe sometime in a future presentation I'll go through everything more thoroughly so I can give you a synopsis of what they found in there. But for them to devote an entire issue to NRF2, you combine that with the fact that they had the first ever international NRF2 conference. All these pharmaceutical companies are getting on board developing NRF2 activating compounds. yes, this thing is about ready to take off. The entire world is going to know about Nerf2 in the very, very near future. And in my anti-aging conferences, I had mentioned that they're starting to talk about this Nerf2 pathway and what an important thing it's going to be. And one of the speakers at one of the conferences I was at in April of 2014 stated this. He said, Nerf2 is a revolution in science and is the most important anti-aging pathway in the human body. Now, the article from Washington State University summed it up like this. We may be on the verge of a new literature on the health effects of Nerf2, which may well become the most extraordinary therapeutic and most extraordinary preventive breakthrough in the history of medicine. It doesn't get any more profound than that, guys. This is a big, big deal, and you're hearing about it so early on. Imagine if you had this information about some other technology like iPhones or Samsung Galaxies before they came out. So you need to decide what you're going to do with this information. If this is something that you're going to share with other people or if you're going to keep to yourself. My recommendation would be to share this with other people and let them experience the benefits of Nerf2 activation as well. So thank you guys very much for your time. I appreciate you taking time out of your busy schedules to be on this webinar tonight. We will certainly be doing more of these in the future, talking about new science that comes out, and anything new in the area of Nerf2, we'll be sure to keep you updated on. Have a great night. We'll see you all soon. Bye-bye.